defensive, but also offensive cloud security. This includes AWS, Azure, and Google Cloud Platform. For the last 2 years, my focus was highly on cloud security, mostly the offensive part. During this time, I performed numerous cloud security configuration reviews, cloud security architecture consultancy, cloud exploitation, and I was also involved in doing research, developing tools, writing articles, and talking at international and local conferences about cloud security. This is our summary for today. We will start with some introduction about what is cloud security, and we'll dive further in the issues, the challenges, solutions. We'll have a demo, and we'll arrive at conclusions at the end. So about using cloud. You can use cloud to host entire on-premises infrastructures in a platform, which is very powerful. Cloud also offers segregation between solutions, meaning web applications, for example, and your internal network. So this is an advantage, because if the web application is compromised, that doesn't necessarily means that your internal infrastructure will also be compromised. Most organizations, especially the big ones, they adapt a hybrid approach where the internal network is interconnected with the cloud resources. This means single sign-on, communication with the Active Directory, and so on. Most cloud platforms offer a shared responsibility model in terms for security, meaning that they secure their services so that they are not exploitable, but it's also your responsibility to use the services in a safe manner. This is a diagram just to show how complex a cloud environment can be, where we have a lot of computing resources in cloud, communicating with on-premises resources, the Active Directory. We have single sign-on, and so on. Now let's talk about the issue. So what we noticed during multiple cloud security configuration reviews is that organizations do not have yet the maturity level of as performing internal penetration testing. And we saw that in case a cloud environment is breached, then in most times the attacker can fully compromise the environment. And the mentality as it is now is I'm using cloud, so I'm secure, which is not the case, especially if you're not implementing the proper control mechanism and detections for identifying ongoing attacks, breaches, and so on. This mentality, I'm using cloud so I'm secure, is not entirely false. In most cases, it's better to use cloud than hosting on premises, but it's definitely not true, as we will see further with some examples from real life. We identified critical misconfigurations that fall in multiple categories, one of them being client data being publicly exposed to the internet. This was from buckets, from VM snapshots. Then we have complete compromise of computing resources, which is another issue that people do not pay enough attention because they think that because since the computing resource is not publicly exposed, then it can be hacked. But in fact, it can be, and in most cases, the cloud platform is actually the let's say the tool for compromising those computing resources. We have a lot of privilege escalation and environment takeover. An environment, when it gets complex and the bigger it gets, it tends to have um, users and roles with multiple permissions that are not in fact required, and combined can be abused in order to uh, escalate privileges. Another issue is that these vulnerabilities and misconfigurations are hard or impossible to identify from web or network penetration testing. And we saw a lot of clients that relied on penetration testing, web penetration testing, for example, to make sure that their cloud environment is secure. And this is very far from the best approach. And we'll see later what is the difference between performing penetration testing and cloud configuration review. Another issue is that a lot of environments, they do not have mitigations in case a breach occurs. So they either don't have proper logging in place, proper detection controls, or simply they are not able to respond to a breach unless they manually detect it and manually fix it. And this is an issue. Now, some examples from real life that falls in the category of I'm using cloud, so I'm secure. I'm not saying that these organizations thought that because they are using cloud, they are secure, but it just shows how bad it can be a cloud breach. Here we have the FTX breach from 2023. This was a cryptocurrency company that hold all client private keys in a single AWS account, and even more, the keys were stored in AWS Secrets Manager, which is a bad practice because you can access AWS Secrets Manager just by having the permission to do so. You don't need to have like a physical key to decrypt the data and so on. And because of this, an AWS account with permission to read secrets from AWS Secrets Manager was compromised, and all or a part of the private keys were exfiltrated. Because they didn't have proper detection and prevention controls. They didn't identify from the start and didn't stop the breach. And as a result, over $400 million were stolen from clients of the company. Next, we have the LastPass breach from 2022, where and this is an interesting one because a personal laptop from DevOps was compromised. It was compromised with a malware for keylogging. The attackers exfiltrated the master password and 2FA for logging in and ironically LastPass, and they used the credentials to access the cloud environment. They managed to exfiltrate a backup of a vault with customer data. As a result, a lawsuit was started against LastPass, and an analysis says that over $35 million was stolen from multiple individuals as a result of this breach. Another one, we have a Tesla breach from 2018. They had in a Google Cloud platform a Kubernetes cluster, and the administrator portal was exposed to the internet. They had as environmental variables a pair of AWS access keys, and the attackers used those keys to install crypto miners in the AWS account. Next, we have the Imperva RDS snapshot breach. RDS stands for Relational Database Service, which is a service from AWS. They had an EC2 instance, which was not used anymore, but the instance had a role attached to it that had permissions to read the snapshot of the database. And this database contained emails, hash passwords, and API keys of clients. And the attackers managed to exfiltrate those data. Moving forward on common entry points for attackers. Talking from the internet, we have public resources like buckets and storage accounts and VM images that are misconfigured and are publicly exposed to internet. We saw this, I wouldn't say a lot, but it happened a few times with client data, financial client data being stored in public buckets that were accessible from anywhere from the internet. And also a strange case where some virtual machine snapshots were publicly exposed to the internet, and anyone who knew about those snapshots, they could have started EC2 instances based on that snapshot. And looking through that snapshot, you can find source code, credentials, and so on. Another entry point is accidentally expose cloud access keys, credentials, SSH keys. This happens a lot, but mostly for smaller organizations. They, by mistake, push access credentials in the Git repository. The Git repository is public, and people are just searching through the internet for this kind of access keys. And until recently, a lot of access keys was found. Now there are some mitigations in place put by the GitHub, for example, so that even if you push your key, you will be notified, but it will be also hidden. Next, we have internet-facing web applications. This is maybe the most common entry point for attackers, because web applications, they can have vulnerabilities, and if the attackers find the vulnerability, they can get a foothold inside the AWS account by either exfiltrating access credentials or by running code on that machine and communicating with other services. And we have internet-facing databases, which even if they have authentication in place, if the authentication is not strong enough or it has default passwords, then it's again an issue. And databases, as a best practice, should be always private and only accessible by the web application or other services that actually need to communicate with the database. And we have social engineering on cloud engineers. I think this attack vector and entry point will never die. It's not much to do about it except for doing social engineering campaigns and trainings, but in the end, it's a possibility that attackers will manage to compromise at the right time the account of a cloud engineer. Now, from internal networks, and here we are mostly referring either from the on-premises network or from a private network deployed in cloud. And we have again exploiting web applications, even if they are exposed only to the intranet. We noticed that these applications, the one that are not meant to be viewed by the public, they tend to be developed less secure, and they actually contain more vulnerabilities than the ones exposed to the internet. Next, we have exploiting continuous integration pipelines, which is not so easy, but it's extremely dangerous. Imagine pushing malicious code into a branch, and that branch triggers a pipeline, and the code will be published for every user that uses that application. And basically you can compromise either every user, or you can compromise the server. Either way is dangerous. We have searching for cloud keys, credentials, and SSH keys, which are more likely to be found on local machines or servers, or all kind of shared drives. And we have something interesting, insider threat. For a few years, there is a trend of initial access brokers, which basically they are selling their access inside organizations to ransomware groups mostly. And it's very hard to protect yourself against this. The best way is to make sure that you add the proper controls, so that even if someone has access to your cloud environment, they will not be able to do a lot, and your cloud environment is secured so that no privilege escalation is possible. You have the proper logging and so on. This is an article from 2021, which talks about how actually ransomware groups are searching for initial access brokers, so that they can get a foothold inside cloud environments. Because yes, most cloud environments, they are not public. It's hard to get there. And that's why it's important to have this in mind, that someone might get in your cloud environment, and you need to make sure that in case they do, you are prepared and there are mitigations in place to limit the breach. Moving forward, let's talk about what are the risks. We have some technical risks at first. So you have data exfiltration, either client or confidential data, maybe source code, maybe secrets from other environments. Another risk is that from the cloud platform, maybe the attacker can get to on the on-premises network, which is possible with complex environments, with maybe SSH keys stored in the cloud platform, and so on. Billing costs, just as in the case of the Tesla breach, where the attackers spawned crypto miners in the AWS account. Another risk, inserting malicious code in running services, which will affect the whole application, its users, and maybe other services that interact with that application. And ransom. I'm not saying ransomware in the classical way of losing your data and wanting the decryption key, but rather ransom for not disclosing the confidential data, the client data that the attackers exfiltrated. So that kind of ransom. Now, other risks. You might have compliance violations and fines, reputational damages, loss of trust, lawsuits, and financial losses, of course. These are things hard to quantify, but they can be very big and can put a company to its knees. Now, let's talk about what it means to have a secure cloud implementation. I have to say that it starts with architecture. You have to implement segregation between solutions, meaning that if you have, let's take the example of AWS, where you have AWS organizations, and you can create a new AWS account for each solution that you want to deploy. This is important because in case a solution gets compromised, it will not affect the other solutions, or it shouldn't affect it. Segregation between deployments, just the same as you have multiple accounts for solutions, you should have multiple accounts for dev, stage, testing, prod, or any other deployment strategy you are using. This is also good for not allowing developers accessing production data, testers accessing development, and so on. You need to have a central logging architecture so you already have segregation between accounts. In each account, you should perform logging, and the logs should be sent to a central account. And the reason for that is it's easier to monitor the logs from a single place. And second, in case an account is compromised, then the logs should not be able to be altered. Log monitoring, yes, very important. You should have alerts. You should have automation in place for remediation, and all of this is hard to do when you are not even logging, right? You need to have a centralized identity management. So instead of creating users in every account, because let's say you have segregation between solutions, right? So you shouldn't make users in every segregation, but you should rather have a central identity management account where everyone will use single sign-on, and from there they will access other environments. You should have global identity access management policies, meaning that you should set at a higher level what everyone should not be able to do, either for everyone or for specific users. You should use infrastructure as code. So you start by having a baseline of security, which you transform it in infrastructure as code, and you make sure that each segregated solution will have a baseline of security that will not be possible to tamper with, and it will be the same in every account. And as I mentioned earlier, alarms with automation in the background that will apply corrective measures. For example, a pair of AWS access credentials is used from an IP address known to ransomware groups, and an alarm should trigger automation for deactivating the access credentials. Continuing with the architecture part, You should apply the least privilege principle, meaning that you give the absolute minimum permissions for someone so that they can do their job, but not anything else. You should perform logging in every environment. You should be able to answer who did what, where, and when. You should log API calls, network communications, changes in configuration, data access. You should use services for threat detection and prevention. Most cloud platforms, or at least the big ones, they have uh, pre-built native solutions that will notify you if someone tries to attack your environment. For example, in AWS, there is guard duty, which will notify you or it will raise an alert if someone uses the Kali Linux operating system for connecting to the AWS account. Now, moving forward to hardening configurations, you should,
Maybe if I
yes,
can, sorry to interrupt, we have a question in the chat.
yes.
Um, it's a pretty long question, but if you can read it. So it says, what do you mean by application? They tend to be not secured. Is there a purpose to develop unsecured application, or is it just a lack of experience, insufficient testing, or legacy applications? Or you are referring to the bad habit that when someone develops an application for internal use only, then security is left out.
Um, so it's definitely the last reason. Yes, there is a bad habit of not properly securing internal applications because the reasoning behind that is no one outside the organization will access it, right? But it's also using legacy applications that maybe the whole developer team that was initially on the project is not working there anymore. No one knows how to fix or change the application, and the application just runs, is not getting any updates. And I would say is a combination of these two, but mostly for internal applications, people tend to just rush things and not address security from the start or ever. I hope that answers it. That answers it.
I also asked you to unmute if you have any other things to add, Robert.
And in the meantime, I would also like to give an example. I worked as a web developer some time ago, and internal applications were allocated to junior developers, to developers in internship. So it can be less secure just because of the lack of experience of the developers.
Okay, I see Robert doesn't have anything else to add. Okay, then I think you can continue. Thank you.
Thank you. Okay, regarding hardening configurations, you should have encryption at rest and in transit wherever possible, either it's bucket or just network communication. Minimizing exposure. So making sure that data that shouldn't be publicly exposed is not. Um, Reducing the exposed ports, the IP addresses that can connect to a certain a certain service, applying patches. So even for cloud native services like databases, they are still using technology that, let's say, MySQL, right? And if the MySQL engine has a vulnerability, then you should apply the patch uh, from the cloud service. So this is still something that you should manage and do it. Stopping privilege escalation vectors, and I know this is a hard one. It requires someone to analyze your environment and look not only through each separate user or role, but they should look at how all the identities from the cloud environment are working together, because you might have a privilege escalation vector that starts with a user and ends um, by combining the permissions from another user. But applying the least privilege principle should help in mitigating this. Um, and yes, we have applying security best practices for each service, like for EC2 instances. For example, you should use metadata API version 2, which is safer than the version 1. And various services will have various configurations that can further improve the security. And another thing is using the proper service for the job. If you have a static web application, it might not make sense to use a Kubernetes cluster to deploy it and expose it to the internet. Rather, you should use like maybe a bucket or an instance for that reason. You have to impose strong authentication. You have to enforce two-factor authentication, maybe limit the IPs from where user can authenticate. And you should perform periodically configuration reviews just to make sure that the security state of the environment is at a baseline where you are comfortable that in case a breach occurs, it will not be game over. Now, moving forward to challenges. Challenges about implementing secure cloud. First off, architecture issues are hard to fix. So if you don't start from the beginning with a good architecture, it might be hard or impossible to change it afterwards. And we are seeing this in clients that we work with on multiple projects, where we report the same vulnerabilities that are related to architecture, and they are not fixed from project to project because I guess it's just too hard to fix it across every environment. Next, we have automation with vulnerabilities. They require fixes on existing environments. This is something that we again are seeing in our projects. So I was talking about that automation that puts a baseline in every account. Well, if that automation is not done properly, then you not only you have to change the automation from that point forward, but you have to revisit the previous deployments of that automation and fix that as well. And that might introduce breaking changes. And yeah, we saw that people are just not fixing this. I guess it's just too hard. So it should be done good from the start. Privilege escalation vectors can be complex and not obvious from the start. We have clients that have dedicated teams of cloud engineers, which are experienced and good, and we are able to identify privilege escalation vectors by combining permissions from multiple resources. Like a user compromises a Lambda function, that Lambda function spawns an EC2 instance, and in the end you have administrator. And they understand the issue right after the moment we tell them, but it's just hard to identify it before it's deployed, because without the proper, I would say, the proper mentality of hacking the environment, you will not look for this kind of issues. Applying least privilege is difficult, especially when thousands of granular permissions must be known. We are seeing this a lot. For everyone, is easier to apply a bigger policy that gives a lot of permissions, so that you make sure your resource can do its job. But by doing this, you are violating the least privilege principle. And if that resource is compromised, then the attacker gets a lot of permissions. And that's exactly the thing that you want to avoid. And of course, mistakes can be made. There's not much to say about this. They happen, and sometimes they are caught in time, but sometimes they are caught by attackers and exploited. I think this is the last. No, we have two more. The cloud hacking is continuously evolving, and defenders might fall behind. It's already hard for defenders to keep the pace with every change in the cloud platforms, which happen frequently. Um, but to also keep change with how attackers are abusing cloud services and perform various attack vectors is another thing that it may not be easy for everyone to follow. This is the last challenge I've wrote: trusting third parties with your cloud environment. We are seeing this. Even if we have a reputation and a name being from KPMG, it's not that the client doesn't trust us to handle their environment. They are just not trusting anyone. They don't want external parties to look inside their cloud environment, which is weird, but is bad for them. Even if you think that it's like performing code reviews when you develop software. You need a party to review your code, and this goes even further, because you should have an external party that reviews your cloud configuration, just because you are so familiar with that environment that you might not look with a fresh mentality in what can go wrong. Okay, now I'll present some examples from our engagement. These are actually findings from my projects. First one is remote code execution as admin on any EC2 instance. If you're not familiar with EC2 instance, it's basically a computing resource, is like a virtual machine that runs in AWS. This was found with manual testing. We managed to exfiltrate the access credentials for that instance via the metadata API. This is an API that runs in every EC2 instance and is not only in AWS, but it's also present in Azure and GCP. And with that access credentials, we basically got the same permissions as the EC2 instance, which, if you look in the right side, it contained the policy Amazon SSM full access. And with this, we were able to send commands abusing a native functionality from AWS that allowed us to run code as administrator on any EC2 instance, either under root or under anti-authority system. This opens a lot of issues besides the ones the vulnerabilities specific to compromising a host, we have this cloud vector where we can elevate privileges by exfiltrating access credentials from other EC2 instances. And we can also go deeper in the cloud environment and looking for more misconfigurations and more things to attack. And this is how the credential exfiltration works. So we have remote code execution using the run command feature from AWS. We perform a HTTP GET request to the metadata API endpoint that is present above the first arrow. This will return us the role name that is attached to the instance, and then we perform another HTTP request. We include the name of the role, and we get the access credentials. And this attack vector is especially bad for defenders, because even if the EC2 instance is private, so it's not exposed to the internet, you can perform this from the internet. It doesn't matter because it communicates through AWS. And this is how it looks from a practical point of view. We have the AWS CLI using the send command feature from the SSM service. We specify a few things, but the important aspect is that we send the command to perform an HTTP GET request to that endpoint. In the response, we will get the role name that is attached to the instance. Then we add the role name and perform another HTTP request, and we get the access credentials, which basically will give us the same level of permissions that the EC2 instance we are targeting has. Another example, we identified some public Amazon machine images, which are basically virtual machine snapshots that were exposed to the internet. It's like making a snapshot of your local VM and you put it in the internet for everyone to download it and use it. And as you can imagine, just as having a local virtual machine, you can have source code there, you can have credentials, you can have SSH keys for other servers and so on. Next, we have credentials stored insecurely. So often we find credentials like Active Directory credentials, AWS access keys, or APIs keys stored in services from AWS like Parameter Store, which stores most of the parameters as plain string, not encrypted, not hidden, and it's just a lot easier to have the permissions to have the permission to read the parameters from this service than it would be to have the permission to read it from a more secure service like Secrets Manager. And we are seeing this all the time, like tens of identity access management identities have read permissions over parameter store. And when we compare it with how many identities have permissions over SSM, over AWS Secrets Manager, we notice that only a few of them have. And this brings a risk of credentials leakage by allowing multiple parties to read them. As a last point, even commercial tools can detect this issue because the tools are not looking at what's inside the parameter, and it most likely not tell you that it's a bad practice, and we actually saw this in an environment that was using Wiz.io, and that environment had stored in parameter store a pair of AWS access keys, and there was no issue reported from is.io about that practice. So it's something to keep in mind when you want to rely more on automation rather than actually having someone review the environment. Storage solution exposed to the internet. I I briefly discussed this already with client data exposed for everyone to see. We identified this in Azure, in GCP. I will not get into more details now. Um, this is an interesting one. So we were performing a Kubernetes and AWS configuration review, and the cluster that was deployed through EKS had had some misconfigurations, so that we, having access to a pod, we were able to exfiltrate the AWS access credentials of the worker node, and using those credentials, we read some Active Directory credentials that were stored from parameter store, just like we discussed previously. And basically, this completes a big attack vector. Imagine having a vulnerable web application running in a pod in a Kubernetes cluster, and from that web application exposed to the internet, someone can get in your AWS account, and from there to your on-premises network. Now, moving to solutions. You need to have security in mind when designing your architecture right before starting to implement it. Most cloud providers have guidelines on how to do this. A good example is AWS Well Architectured Framework, which goes behind security. It covers availability, um, reliability, and other things. You should review the design with a cloud architect or cloud security specialist before implementing it. This is especially important because you are doing it once, and then you can start developing your architecture, and you don't want to have to make changes later on, because as we discussed, architecture issues are the most time consuming and hard to fix issues. When you are adding automation, make sure to double check both the design and the scripts before starting to deploy solutions based on them, because you will have, in case there is an issue, you will have to review every deployed instance and perform the corrective measures. As a recommendation, you should review the infrastructure as code on the first iteration. So before you are actually using it in production, or when major changes occur. And I recommend this from the bottom of my heart. You should perform cloud security configuration reviews just as you want to perform internal network penetration testing. Is the same thing. Just because the cloud environment is, let's say, closed to the internal employees or internal network, someone can get in there, and it shouldn't be game over if they do. You should be able to mitigate a breach, to identify one, and to have all the mechanisms that will help you in performing an incident response flow. Okay, now let's talk a bit about cloud security configuration review. There are two ways of doing this. The first one is doing configuration review, which is like a white box approach because you have access to everything. You have read-only permissions. You don't need write permissions for this. This might result in some false positives, like you identify an attack vector, but maybe there is a global policy at a higher level that you don't know that will prevent that attack. But either way, it's good to do it with read-only permission and have the client validate in the end, or um talk with the client if you can get some right permissions just for you to validate that that attack vector is indeed possible. You can identify hardening configurations, attack vectors, misconfigurations, architectural improvements, security best practices. And the other way of doing cloud security configuration review is by having an insider threat simulation. So this is more like a gray black box approach, where you want to assume that something was compromised, either let's say a developer account or an EC2 instance, something with permissions, right? And you want to see how far an attacker can get from that point. Since you don't really control the permissions because it's specific to a use case, this scenario might have more than read permissions. It might have, as consequence, some modifications to the environment. That's why we recommend to do this on staging environments, not production, because it might break things. And another advantage of performing an insider threat simulation is that you can have your defenders to practice and improve on monitoring, detection, and remediation. It's like an exercise for them before anything bad really happens. Now let's talk about automation versus manual configuration review. In my engagements, I mostly rely on manual configuration review, but I'm also using some automation at the beginning for enumerating the environment. But in terms of identifying vulnerabilities, I'm not relying on automation, and here's why. So the automation is fast, but is mostly based on one command checks. Is useful when a service contains a high number of resources. So if you have thousands of I don't know, buckets or EC2 instances, then yes, automation for checking a certain configuration among every instance, yes, it's the only way to go. It might provide false positives, and it most likely will provide false positives that are not in fact vulnerabilities. And it does not cover cross account analysis. As I talked about segregation between solutions, it's also common to have some resources between the solutions communicate with each other, like a role from one account can assume a role from another account. Well, the automation does not cover this kind of analysis. Now, moving to manual testing, yes, it takes more times, but you can identify complex misconfigurations. You can identify logic issues, can identify weak points that might impose a security risk. And it's good for cross-account analysis because you can see exactly who can do what on what other account, and you can look exactly at the permissions and how the whole image is presented. Now we're getting closer to the end. This is also where I will present you a short demo. But first, let's talk about shifting the mindset. Is penetration testing enough? Well, I would say no, and here's why. So let's take, for example, this architecture, and let's assume that we are comparing a web penetration test versus a cloud configuration review. So we have an EC2 instance running running the web application, and behind that web application, there are some communication with an S3 bucket, Lambda function, API gateway, another EC2, and so on. Now, when we are doing web penetration testing, we are actually covering only what is inside the EC2 instance. And in some cases, if the penetration testers are not familiar with cloud attacks, they might not even identify low-hanging fruits that will otherwise be identified by someone with some cloud experience. But what's important is to know is that it covers what's inside the EC2 instance, and will most likely not cover what's behind it, because it doesn't the tester does not have visibility on the API gateway, the S3 bucket, the Lambda function, and so on. And when you're performing a cloud configuration review, you basically cover everything else except what's inside the EC2 instance. So in a sense, the penetration test and cloud configuration review are complementary. They complete each other. But when you're performing cloud configuration review, you cover what is inside the AWS environment, and you're not looking what is inside the EC2 instance or what web application is exposed through that. However, the advantage of performing cloud configuration review is that you can also find some things that will mitigate a breach. Let's say the web application has a a vulnerability of server-side request forgery, and the access credentials from that instance can be exfiltrated. Well, you can mitigate this from the cloud configuration review, because you can identify the hardening configuration from the instance that will prevent it. And we'll see this shortly. So the configuration review will identify vulnerabilities at the web application? No, but it will provide mitigations and misconfigurations. The web penetration test will do the exact opposite. So it will identify vulnerabilities at the web application level, but it will not provide mitigations and misconfigurations from the cloud environment. And we will go into a short demo where we will see how easy it is to exfiltrate some access credentials, and what is the difference between a penetration tester, a real attacker, and a cloud configuration review. But before we start, I wanted to ask if there are any questions.
You can raise your hand, or you can write in the chat, and I will unmute you. If not, maybe I have a question.
Yes.
Have you considered this part of a cloud configuration review also taking into account zero trust principles and the zero trust framework, maybe to bring them together somehow?
I'm not familiar with the framework. If you can summarize it a bit, it will be helpful, because I have an idea about it, but I'm not sure it's the right one.
Yeah, I was thinking that there are multiple, let's say, approaches now, but the main one which I'm more familiar with is the one from NIST. So they explain a bit the zero trust architecture and how to approach it when creating the infrastructure, in the sense that even if you are inside the infrastructure, you still consider that everything is a stranger, so you do not
Yeah,
trust the communication with another application or things like that.
yeah. So kind of this is how it should be viewed the cloud environment, because you need to have some sense of zero trust, especially for uh, user accounts. And you must ensure that even if that account is compromised, it will not affect the whole environment, or at least it will uh, be mitigated. So yes, you should go towards a zero trust approach as much as it's possible.
Mhm. Super. I see also Victor has raised his hand.
Thank you very much. Regarding the zero trust, actually, we can extend the topic of discussion a bit, because we have some legal requirements. By the way, can you hear me?
Yes.
Thank you. Okay. We have security by design, security by default as legal requirements. Some of best practices are recommending segmentation, micro-segmentation, zero trust, meaning one-to-one secure connection in terms of, let's say, organizational behavior. We are talking about implementing and enforcing some security policies. Are all these, if properly installed, established, are all these enough to put an organization at the safe side?
Um, well, yes and no. It's definitely good and safer to go with this approach. But as we say in the industry, there's never 100% vulnerability free or security assurance, right?
Yes.
So, yeah, imagine having your cloud admin account compromised. I mean, what can you do about that, right? So I wouldn't say it's enough. I don't know if there is anything enough to say you are safe, but it's safer to do it this way. Definitely, it's better.
And also in comparing with the traditional way of using the infrastructure and moving towards forward to a hybrid or cloud-based, are there any particular um, topics or particular policies real specific to cloud that should be added, or the user behavior and the user perspective should be as it was defined within the traditional the infrastructure. So meaning that the security is the responsibility of everyone. Everyone should
Mhm.
contribute to security and so on.
I think here is not the case because not everyone should have access to the cloud environment. I'm laughing because I just remembered that in one engagement we saw hundreds of employees having access inside the AWS account, which is definitely bad. Like, you don't want to have that. I would say that only the people that are required to have access to cloud should have access.
Least
But
privilege, as you mentioned.
yes, but among the persons that have access, I think yes, the security falls for everyone to be put in place. So it's a responsibility for the user that has access to the cloud, but not every employee should have access to the cloud. Okay, good. Let's move forward, and we'll take more questions as we go, or at the end. And thank you for the question, Victor. So we'll see in this demo how we can exfiltrate access credentials from a vulnerable web application hosted in EC2. And we'll compare it with a real attacker, a penetration tester, and a configuration review to see all perspectives. I had a nicer web application, but today it stopped working. So I made a quick one. But let's imagine it's something more complex and just as in real life. We have a web application. Let's say we are doing a penetration testing on it. And we identify at some point that we have an URL that allows us, we have a query parameter inside the URL that allows us to perform server-side request forgery. Server-side request forgery is a vulnerability where we make the server, the web server, performing HTTP requests with arbitrary hosts. Like, for example, I performed a request to google.com and it showed me the output. Well, first off, I would like to say that a penetration tester might not even go into the cloud specific attacks, like we will see next. So your report will only say that you have a server-side request forgery, and the risk will be somewhere around medium to high, but it will not go into the real impact of the vulnerability. Now, let's say the penetration tester has in fact some cloud experience, so they will attempt to read data from the metadata API, which is an API running on every EC2 instance at this address, 169.254, 169.254. And with this metadata API combined with the server-side request forgery, you can exfiltrate access credentials. And as you can see, you even have an directory enumeration vulnerability that will tell you exactly what you can access. And we are looking for where is it? For YAM, which is identity and access management. Going here and with security credentials, right? We get the name of the role that is attached to the EC2 instance. So this role gives the EC2 instance permissions. And once we have this role, we can just append it here. And we get, as a response, some temporary access credentials, which we can use them to basically get the same level of access as the EC2 instance. Now, let's reiterate. We are a penetration tester. We got to this point. We might stop here because going into the cloud might be outside of the scope of the engagement. Not every client is open to going further, going beyond the scope. So we might not even check what these credentials can do. And even if we as penetration testers will check the credentials, we will not perform write operations, right? Because the last thing we want to do is to break the environment with modifications, changing configurations, and so on. So that's the most we can do as penetration testers. We will check some read permissions using these credentials, and we will include them as a risk in the report. Now let's think from the perspective of a real attacker, which not only it will identify, I mean, having more time is more likely to identify this issue, and having the cloud knowledge, it will the attacker will get to this point where they exfiltrated access credentials, but they will not limit themselves only to read permission. They will try to exploit, to escalate privileges, to exfiltrate sensitive data to obtain something from the environment, right? And that's a big difference that you will not, so you will not know the impact from a penetration test regarding this vulnerability, which I think from the start is a big difference. Now let's look at the actual configuration of the instance. So this is the instance with the web application. And we want to check the permissions attached to the instance. We will go to this role. I hope the font is big enough. Okay, and here we can see two policies. The Amazon SSM managed instance core. This is a policy that usually it's on every EC2 instance from every AWS account because it allows cloud engineers to monitor the instances, right? And we have a custom policy, which has these actions: SSM send command, list command invocations, and describe instance status, which opens the vulnerability we discussed from our examples, where you can send commands to other EC2 instances under high privileges, right? And this permission with EC2 describe instance status can be used to find what instances are in the AWS account. So I, for one, as a penetration tester, I don't think I will try this because it might trigger a whole incident response flow. It is just too much, right? But an attacker having enough time, wanting to compromise more things, at some point they will get to identifying that you can do these things. And let's see the other EC2 instance that we have inside this AWS account. So looking at the second instance, we can see that this instance has also a role. And when we check this role, we can identify that, well, for one is the same policy, but that's not important. We have a custom policy that basically contains a privilege escalation vector. And imagine that this instance is used for, I don't know, enrolling new users in the cloud platform for whatever reason. And you have the permission to create user, to create access keys for user so that you can obtain access to the user. And you have attach user policy, which can be abused to escalate privileges to administrator, because you can directly say, okay, create a user, make it administrator, and then create access key for that user. Again, comparing a penetration tester, I don't think a penetration tester will get here only from doing a penetration test on the web application. An attacker, they might get here, right? Trying various things, running commands on this instance, exfiltrating the access credentials, and then trying with the new set of credentials ways to escalate privileges. I think the attackers can get to this point where they get admin access inside the AWS environment. And now let's look from the perspective of a configuration review. So, but one more thing I would like to add before that, if this was in a penetration testing, it will take like a week, right? 5 Mondays to, I don't know, get to this point or cover the application and maybe not identify the issues. If it's a real attacker, then time might not be an issue. 1 month, 2 months, they might get here. They don't care. But from a configuration review point of view, we can firstly look at the instance. First thing that I would check would be instance metadata service version 2, which is optional, and I would make it a finding because it should be mandatory. This is the service that is abused for exfiltrating access credentials, and as we saw here, it works by performing GET requests, the version 1. But the version 2 requires a token that can be obtained only by performing a PUT request, HTTP PUT request. And that's a big difference because server-side request forgery in a web application will not be able to be abused to exfiltrate access credentials. And that can make the difference. So a simple setting from optional to mandatory, actually the term is required here, but this will make the whole difference between being safe and having your AWS account completely compromised. So that's one thing. The same goes for the other EC2 instance where I will check the same thing, but now looking at the role. Well, knowing these permissions or having access to them and being able to search on the internet for them, you can notice that they can be abused for running remote code on other EC2 instances. This is a complete attack vector for compromising other EC2 instances. This will be another finding. And going to the permissions from the second one, again, just from a look, it will be obvious that the permissions from this policy can be abused to escalate privileges. And this is an example starting from a public web application that has a vulnerability. But imagine that you have a developer that can connect to this EC2 instance. Well, they can perform the same thing because the developer connects to the EC2 instances and has access to the permissions of the instance, and the developer can escalate privileges. And if the developer account is compromised, then yeah, the attacker can do the same thing. That was for the demo. Now to summarize it, so if you're performing a web application penetration testing, you might not even identify the server-side request forgery vulnerability. You have no direct way to identify what version of the metadata service is in use, if it's version 1 or version 2. The right permissions will not be enumerated, but with a real attacker, you have more, not you, but the attacker has more time available to attack the web application. Most likely, they will not limit themselves to only read permissions, whereas the configuration review can quickly identify the version of the metadata service in use. And as with most cases, or at least some obvious one, this kind of privilege escalation vector can be quickly identified from just taking a look at the permission. Good. Now we have one more chapter, which is not so long before conclusions. And I want to talk about extensions to cloud, because cloud is actually more than a cloud provider. Cloud is Kubernetes cluster, continuous integration, pipelines and flows, distributed version controls like using GitLab, GitHub, And we actually did some configuration review on GitLab server and GitHub servers. And we identified that there are repositories where developers can push code directly to branches that trigger continuous integration pipelines. And those pipelines are deploying the code to the cloud. And now imagine this scenario where the developer account is compromised, malicious code is inserted in the source code repository. That source code goes directly into a branch that triggers the pipeline, and the code arrives in the cloud environment. And this way, an attacker from the internal network can get access to the cloud platform. And we also have containers, mostly used in Kubernetes clusters. Most people have golden images that are images theoretically hardened, used on every deployment. And maybe you should ask yourself if you ever did a configuration review on that golden image that you are using everywhere, because that is cloud too, and that can affect the cloud environment. Good. And conclusions. So using cloud doesn't guarantee security. I think the industry needs to adapt to the security challenges brought by cloud adoption, and they need to do it, I would say, fast, not waiting until they are breached for this. A cloud breach can lead to on-premises access, and a cloud breach can be a complete environment compromise. Performing configuration reviews regularly can decrease the risk of a compromise and the impact of a breach. And classical penetration testing is just not enough. Now, the last slide. So me and my team, we are doing cloud security research and more on our website, securitycafe.ro. You can find me on Twitter at SawyerPacket. This is my contact email address. Now, thank you for being till the end for this presentation. And if you have questions, please say so.
Thank you. Thank you very much for the presentation. Very insightful, and you covered all of the bases for cloud. I would say so.
That was my hope.
Now, if you have questions, so you can write them in the chat or you can raise your hand. I can maybe kick off with a short question. I have a. Did you have any multi-cloud analysis reviews for clients, or have you focused on this area to see what things are used by multiple clouds or replicated applications and so on?
Yes and no. One of my certifications is covering the exploitation of environments that are using multiple cloud providers. We did some projects for solutions deployed. I mean, solutions having components deployed in multiple cloud environments, cloud platforms, for example, AWS and Azure. But I think your question is related to if we cross-checked the same solution deployed in separate cloud solutions, right?
Yes, and the way that they communicate, so that they respect, I don't know, like authentication, authorization, and.
We didn't have a project like this. I mean, we had projects where solutions from components from solutions, components from the same solution were deployed among multiple cloud platforms, and they had to communicate with each other. This, yes, we covered. And what I noticed is, I mean, the most important thing is to have that network segregation put in place, network restrictions, and it should be fine. There are some issues related to access management, because now we need to have a team of maybe the same developers accessing two cloud platforms, double the risk, right? But regarding only the technical part, how the services are communicating with each other, the most important thing I would say is having good network policies in place.
Okay, super. Thank you.
Thank you.
And maybe just one more question from my side. Did you notice some, let's say, differences in configurations for the dev environment, for the test environment in the cloud and for production? Do people focus more on production and leave dev development and testing environments, let's say, not that securely tightened?
So not really, because we have two ways of doing. I mean, the clients are coming with two ways of doing configurations, either directly on stage for which is a replica of the production, or at least it should be so, or the production doesn't exist yet, or they want us to perform the configuration review directly on production. But what I noticed is that the security controls are the same on both environments, because that's kind of a requirement from our side, because it doesn't make sense to review something that will not have the same structure in the future.
Thank you.
In your experience, did you start to use some reference controls for the cloud environment? Like, I have to make the advertising yet. Obviously, we are part of Cloud Security Alliance. The cloud control matrix, for example.
Yes, we are using. I mean, in the beginning, we are using cheese more often, but now cheese is just something in the background that backs up our findings. It's not. I don't know, the main focus. Our project went into a direction of actual exploitation and vulnerabilities with a direct impact, but we also cover hardening configurations that are mentioned by CHIS. And the framework you mentioned, I wasn't aware of it, but I want to check it, because maybe something that I haven't thought of is there, and is definitely worth knowing about it.
It's a valuable document, and I wrote the link I put the link in the chat.
Thank you.
So you can take it from there. Thank you.
Super. Thank you. And thank you once again, Edward, for your presentation. It was very thorough, very well researched, and you covered let's say all the points. Thank you for your time.
Thank you as well.
Now, if there are no more questions, I think we can end this meeting. Thank you all for participating, and we'll see each other next month with the next event. Have a lovely evening.
Thank you. Bye bye.